All right, guys, so this is 4.1c, and chapter 4 is all on systems of equations. So your goal for this chapter is to figure out where my lines intersect, or where they meet. In that point, that ordered pair is called my solution. So just as a friendly reminder, let's look at number 4 here. It says putting the equations into slope-intercept form. We learned in chapter 3, slope-intercept form is y equals mx plus b. So if I'm trying to put c into slope-intercept form, I'm trying to get y by itself. I'll add x to both sides, so I get 4y equals x plus 16. Divide everything by 4, and I get y equals 1/4 x plus 4. Let's try another one just to get our brains thinking math. Let's try b. If I want to get y by itself, I'm going to subtract 4x on both sides. I get 2y equals negative 4x minus 12. Divide both sides by 2. I get y equals negative 2x minus 6. So for number 5 down below, it says consider the linear equations 2x plus y equals 4 and y equals 4x minus 2 from the previous page. Graph both equations on the coordinate plane below. Well, I'm going to go ahead and circle this guy in blue. I need to put him in slope-intercept form. So I have 2x plus y equals 4. I'm going to subtract 2x on both sides to get this in slope-intercept form. Y equals negative 2x plus 4. I'm going to go ahead and graph this. So I go into my y-intercept at 4. I go down 2 over 1, down 2 over 1, down 2 over 1. Now it's going to be important in this chapter that you do 3 or 4 spots or ordered pairs to the right of your y-axis and 3 or 4 to the left. And I'll explain why here in a minute. So we've got up 2 over 1, up 2 over 1. Let me get my straight edge. Connect my lines. Awesome. Now I'm going to change my color. This other equation was y equals 4x minus 2. So if I graph that, here's negative 2. I go up 4 over 1. So 1, 2, 3, 4 over 1. Oops, it's up a little higher. Up 4 over 1. Oh man. So this line looks like it is going through here. And the other line is going, oh man, through here. What you're going to notice are my two lines are intersecting, okay? So it says find the coordinates x, y of the point of intersection. That is 1, 2. So 1, comma, 2. Verify that point of intersection you found satisfies both equations. Okay, so what I'm going to do is I'm going to say the blue line, right, was over here. We had y equals negative 2x plus 4. I know my x is 1, my y is 2. Watch what happens. I get 2 equals negative 2. I'm going to plug in 1 for x plus 4. I get 2 equals negative 2 plus 4 is 2. Is 2 equal to 2? Yes. Now I need to prove it that this is a solution to the other equation. My other equation was y equals 4x minus 2. I'm going to plug in 2 for y. I'm going to plug in 1 for x and solve. I get 2 equals 4 minus 2. So 2 equals 2. The solutions to a pair of linear equations is a pair, if any, of numbers x, y that are solutions to both equations. The x, y satisfies both equations. Okay, when solved graphically, the solution is the point or points of intersection, if there is one. So they want to know, determine whether 3, 8 is a solution to the following systems. Okay, so I'm going to go ahead and try and prove here that it works for this one. Here's x, here's y. They want to know, is this a true statement? Is it a solution? If it is, the statement will be true. So 2x would be 2 times 3, okay, plus y, which is 8, is 14. I get 6 plus 8. Is that equal to 14? Yes. 14 equals 14. So 3, 8 is a solution for the top one. Let's check out the bottom one. X plus y is 11. My x was 3. My y was 8. Equals 11. 3 plus 8 is 11. 11 equals 11. Yes. 3, 8 is a solution. Determine whether 0, -5 is the solution to the following systems of equations. Okay, so x will be 0, y will be -5. I'm going to plug this in to the top equation. I'll get -5 equals 2 times 0 minus 5. -5 equals -5 because 2 times 0 is 0. 0 minus 5 is -5. Yes, that works. Okay, for this bottom one, we get 4x, so it'll be 4 times 0 plus 5 times -5 equals 25. Well, it looks like it's working. 0 minus 25 is 25, but -25 does not equal 25. So no, it is not a solution to both. One is a false statement. So it says consider the equations y equals -2x and y equals -1/2 x plus 3. Make sure both equations are written in slope-intercept form, then graph on the coordinate plane to find the solution. Verify the solution satisfies both equations. So for this first one, I have y equals -2x. That means it goes through the origin. I'm going down 2 over 1, down 2 over 1, down 2 over 1. Again, for this unit, you're going to want to show a few points to the other side of the y-axis. Up 2 to the left one, up 2 to the left one. I'm going to grab my ruler, make my straight edge, and change my color. So my second line starts at -3. So 1, 2, 3. My slope for this one is down 1 over 2. Down 1 over 2. Down 1 over 2. I can see I already have a point where these two lines intersect. And it looks like that point is going to be at 2, -4. Now they want me to prove that it satisfies the solutions. So when I go up above, I have y equals -2x. Well, 2 is going to be my x. -4 was my y of my intersection point. So I get -4 equals -2 times 2. Is -4 equal to -4? Yes. So it works for this equation here. Now I need to plug it into the second equation. I had y equals -1/2 x minus 3. My y for the solution was -4 equals -1/2 x, which was 2, minus 3. So I get -4 equals -1 minus 3. -4 equals -4. So yes, that is a solution. Okay. This next one says, consider the equations -2x plus y equals -1 and y equals 2x plus 4. Make sure both equations are in slope-intercept form, then graph. Okay, so let's go ahead and do this. We have -2x plus y equals 1, or equals -1. I'm going to add 2x to both sides. So I get y equals 2x minus 1. Graph it. Y-intercepts at -1. I go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. I'm going to grab my straight edge and make my line. The other equation was y equals 2x plus 4. That's already in slope-intercept form. So I'm going to go up to 4, up 2 over 1, up 2 over 1, up 2 over 1. Some of you are going to notice that, hey, these guys don't intersect. Why do they not intersect? Well, they have the same slope. And we learned in chapter 3 that if you have the same slope, they're parallel lines. They never touch. So this means no solutions. There's never a solution where they're going to overlap because they have the same slope. Okay. Let's go ahead down here to number 11. It says, in the table below, draw an example of a graph that represents different solving outcomes of a system of linear equation. So something that has one solution, okay, will intersect with another line somewhere like this. That point of intersection, okay, is the solution. It has one solution, it meets once, intersects once. Something with no solution will have the same slope. They're parallel because they never touch, okay? And something with infinitely many solutions will have a line, but what's going to happen is the second line is going to be the exact same. So if I were to graph my second line, it would be the exact same. So you can't really see them, but they're always overlapping. So there's infinitely many spots on my line that would be a solution. So 12 says, without graphing, determine whether the following systems of equations will have one solution, no solutions, or infinitely many solutions. For this one, I have two separate slopes, so they're not going to be parallel, and they're not the same exact equation, so I know this has one solution. They will meet at one point. For this one, if I subtract 2/3 x on both sides to put this in slope-intercept form, I have y equals negative 2/3 x plus 1. What do we notice about these equations? They have the same slope, right? So same slope means parallel lines. Parallel lines mean they'll never touch, so there's no solution. For this next one, when I put it in slope-intercept form, I get y equals negative 2x plus 8. They're not parallel because they have different slopes, and they're not the same exact equation, so this means they will intersect at one point. All right, D, if I subtract x on both sides, I get y equals negative x plus 5. Over here, I'm going to add 2x to both sides, put it in slope-intercept. I have negative 2y equals 2x minus 10. Divide everything by negative 2, I'll get y equals negative x plus 5. These are the same exact lines or same exact equations, so there will be infinitely many solutions because they'll always be touching. Okay, so what I want you guys to do for homework tonight is I want you guys to go ahead and do A, B, C, D, E, you can try F, G, and H. Okay, without graphing determine, I'm going to also have you do A down below, and D and C. All right, we will go over this tomorrow in class. If you need help, be sure to come see me. This is 4-1C, Graphing Systems of Equations.